Hello data scientist, welcome to Skillgate. In this video we shall build an emotion detection model using CNN based deep learning end to end. During the course of this video we'll get a first hand sense of how data scientists think while solving a problem of this scale and complexity by applying a lot of their human sense into what they build. I'm sure I've excited you enough. Let's get started. For those of you who don't know us, we are Skillgate, and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every month, so make sure to subscribe to our channel to get access to all of our free ML projects. Alright then, let's get started. This is our problem-solving framework. We'll go step by step through this in order to understand, solutionize, and deliver on our project in hand. So let's start off with defining our objectives we wish to achieve with this emotion detection model. Simply put, we wish to build a highly accurate emotion detection model that takes human image as input and predicts facial emotion for the subject in the image. In this video, we shall focus on the technical aspects including coding for building this model. If you wish to further deep dive into the business application of emotion detection, I would highly recommend you to go through our age, gender, and emotion detection business project that we have done for a retail store client, enabling them to predict age, gender, and emotion of people entering their store. We are making use of the emotion detection model we shall build now into this age, gender, and emotion detection business project, so do check that out. Link to this video is in the description part below. Now when we have clearly articulated our objective, next up we need to find an adequate labeled dataset for model building. To build a highly accurate model, we would be needing a lot of labeled images for training. Thankfully, a range of such labeled image datasets are readily available on the internet. Here's a crisp summary sheet on some of these publicly available datasets for your understanding. You may pause this video here and go through this sheet if you may like. A word of caution here would be that not all of these datasets are available for commercial use. For real client implementation, we might need to spend more time in identifying or buying labeled dataset that comes with a commercial use license. For our project, we will use CK Plus dataset for building our emotion detection model. CK Plus dataset is a popular and most extensively used lab-controlled facial expression dataset published in the year 2010. It has facial images on 7 expression classes including anger, contempt, disgust, fear, happiness, sadness, and surprise. Images are separated into 7 separate folders named as per these expression classes. There are a total of 981 images in our dataset that we shall work with. By the way, if you are new to machine learning or recently started working with image data, I would highly recommend you to go through our face recognition project as well, where we have used traditional machine learning to solve a relatively simpler computer vision problem. Link to this is in the description part below. Do check it out if you are a beginner. Alright, now let's sketch out a plan on building our emotion detection model with CNN based deep learning. We already have around 981 images with us. We would need to extract emotion labels embedded into the subfolder names of these images. We shall also convert our images to grayscale. Then we define our emotion classes. We wish to predict basis our specific use case. We shall talk about our use case in a minute. Next up, we would use CNN-based deep learning approach for model building. CNNs are really well suited to handle image data, and definitely we can expect a good accuracy coming our way with CNN. We shall be using Google Colab Pro for model building. Let's define our emotion classes now based on our specific use case. So we are building this model for a dummy retail store client who wish to gather data on their store visitors around their facial emotion along with age and gender. By the way, we have already done separate videos on age and gender detection using deep learning. Do check them out as well. Link to these is in the description part below. Alright, let's come back to our problem statement now. So for a retail store that wishes to understand the emotion their store visitors have at the entry point, they don't want to go into the detail of emotion. They simply wish to understand if the emotion is a positive, which is happiness or surprise, or negative, which is anger or sadness, or neutral, which is contempt or disgust or fear. Thus, we are clubbing our 7 available labels into 3 unique labels basis our business need. Now, just to summarize, we have a total 981 labeled images in our dataset. We split that up into 75-25 training and test. Accordingly, we then have 735 images going into training our CNN model and 246 going into testing. Moving on, let's jump into the coding part of this emotion detection model. Let's get coding. If you have already gone through our age, gender, and emotion detection business project, you should be quite familiar with this free toolkit by now. Link to this toolkit is in the description part below. Over here we have this 1.3 input-output emotion folder that has training dataset in the input subfolder and model output files including pre-trained emotion detection model file in the output subfolder. This 2.3 is our code file for emotion detection. Let's open it now to do a quick code walkthrough. Alright, now we are in Colab. I'm using Google Colab Pro as you can see over here. If you wish to subscribe to Colab Pro, just click on Tools, Settings, Colab Pro and subscribe. However, for this emotion detection model, as we have a smaller dataset to work with, you should be able to run this code even without a Pro license. In my case, I do have a Colab Pro subscription, so let me quickly check if my runtime type is set to GPU. For this, I click on Runtime, change runtime type, and I do see GPU selected along with high RAM. We are all good to go. Let's connect to our runtime now. Awesome. Let's go section by section through this code file now to see and understand what our code does. First up, we have our plan of action, wherein we have summarized everything we need to do as part of this emotion detection model building. Next up, we mount our Google Drive like this. Alright, Drive is now mounted. Then we set up our working directory. Up next, we do the import of all essential libraries and functions we would be using. This next section is on importing our dataset. Over here, we first provide the path to our dataset. Then we assign all folder names, which are 7 in total, to this subfolders list. By the way, for the sake of creating this video, I already ran this entire code prior because importing dataset and model fitting do take considerable amount of time. So just in the interest of time, I'll just take you through the outputs that we have for the specific code cells. Alright, in the next code cell, we use a for loop to access every subfolder within our subfolders list for reading images under these. We also read the index of each folder and assign it to label over here. And then we change all labels to previously defined new labels basis this logic, the way we discussed while sketching out our plan. Then we use this next for loop to read images within our subfolders one at a time. Under this, we are converting each image to grayscale and resizing them to 48 by 48. Towards the end, we append each image, the pixels, to this list images and new labels to this second list labels. Next up, we convert our two lists, images and labels to NumPy array. You may also validate the count of images with this shape attribute. As you may see, we have 981 images of size 48 by 48 each. Next up, we encode our labels into three classes. This is a prerequisite for CNN. You may read more on label encoding by following the link in the description part below. Okay, then we split our dataset into train and test in 75-25 ratio. Again, with these next couple of code cells, you may validate our numbers of train and test sets. Now we come to the critical part where we define our CNN architecture. So first up, we have an input 2D convolutional layer with 32 filters paired with an 2D max pooling layer. Then we have three pairs of 2D convolutional layers with 64, 128 and 256 filters respectively, paired again with 2D max pooling layers. Then we have one dense layer with 128 nodes, and finally an output dense layer with 3 nodes, which essentially are our labels, positive, negative and neutral. Over here we are also using dropout in order to decrease the number of parameters we have in our CNN. You may read more on CNN architecture following the link in the description part below. Next up, we are compiling the above defined CNN architecture in this cell. Here's our CNN architecture summary for you. Then we are using model checkpoint for saving our model as it continues improving in performance across 50 epochs. So with this, essentially we are saving a model copy back to our Google Drive post every epoch that has an accuracy improvement. Now we come to the model building part of this emotion detection course. As I said, we are doing 50 epochs for model fitting. This cell might take around 5 to 10 minutes to run. Once done, this is how your results should look like. Over here, as you may see, accuracy keeps improving across epochs as neural network keeps learning from the provided training dataset. Alright, congratulations to you for making it to this point. Your model should be ready by now. Next up, we check for model performance. With these next couple of code cells, we are plotting these line plots for loss and accuracy. For training, we see accuracy keeps improving across the 50 epochs. Of course, there's further scope of improving model accuracy if you do more epochs or by using an even larger dataset with more variation in images. Sky is the limit really. Alright, with this we come to the end of our emotion detection code walkthrough. Our model file shall get stored in the output subfolder in the emotion input output folder in your toolkit. Now let's talk a bit about the business application of this model. We have already done a business case on age, gender and emotion detection for a retail store client. I highly recommend you to go through it now to know how this model we just built could be used for a business application. Alright then, this completes our emotion detection model building video. Hope you had fun all along. Do share your feedback or queries in the comment section below. We post new machine learning project videos every month, so make sure to subscribe to our channel if you haven't till now. Good luck to you. See you in the next video.